Okay, so moving on to our final example. A stop sign is a regular octagon with a radius of 16.2 inches. What is the area? So we have kind of a more real world example here. Here you see the radius, it's a little small, but it says 16.2. The first thing we need to know is if it's a regular polygon, we need to understand what the formula for the area is. And that's 1/2 times the perimeter times the height, which is actually called the apothem and a regular polygon. Okay, so I kind of drew out some breakout pictures. So this is kind of like a zoomed in version of this. So this green is our radius. This black line would be half a side. Okay, so if we're relating this is going to be related to our perimeter. Okay, so if we have one side, we're going to multiply that by 8. If we have half a side, we need to find the full side first by doubling it and then multiply it by 8. And then this red is our apothem. Okay, the apothem is always perpendicular to the base or to the side, and it splits it into two congruent components. So if we were to draw this over here, well, it's hard to see with red, so let me change it to like yellow. Okay, this would be our apothem, and it would split this into two. Let me use orange or something. Two congruent little pieces. So our other radius would help it form a triangle. Okay, and that triangle is drawn here. Now, how do we go about this? We're not given any angles. All we're given is the radius. And so we don't have our apothem. We don't have half a side length. So we have a lot of work to do, it appears. Okay, so the first thing we're going to do is we are going to figure out what this angle is in this triangle. So we know 360 degrees goes all the way around. So we know this is 360 degrees. But we're not looking for 360 of it. Okay, we only want a portion of that. So if I continue drawing some triangles here, how many triangles do you expect I'll have? In this case, we only have 8 triangles. So if we have 8 triangles, we can find the measure of one of these central angles. Okay, that's what I have in purple here, by doing 360 divided by 8. So let's go ahead and do that. So as I try to find my central angle, this top angle here of this triangle in purple, let me just reemphasize right here, this angle, I do 360 divided by 8, because there's 8 sides, there's 8 central triangles, and I get 45 degrees. So this angle right here is 45 degrees. Okay. This is helpful. Why? Well, because that's going to help us. This informs us about this angle here. Well, we know that angle is 45 is double this blue angle. So we're going to do 45 divided by 2 to find this blue angle. Why do I want to split this into 2? Well, the whole point is to find the apothem. And right triangles are much easier to work with, and we can use trigonometry as opposed to having a triangle like I'm going to outline it in blue, as opposed to having this triangle. This triangle that I just drew does not have the apothem, and that's what we're really concerned with. So this is 22.5, and that's really all we need. We don't really need to find this other angle right here, because we're going to use trigonometry to help us find the apothem and the half a side length. Okay, so let's fill in what we know. We know that the radius is 16.2 inches. 16.2, right? Yes. Okay. And let's relate everything in terms of this blue angle. So this blue angle is our reference angle. Okay. This is our reference angle. I'm going to write reference theta, which represents reference angle. Okay. Now, in terms of this angle, what are our sides in terms of trigonometry? Well, this is our opposite side. This is our adjacent side. Kind of nice that the apothem and adjacent side are both together. And then 16.2, our radius, is our hypotenuse. So let's form some trig identities to get what we want. Well, we're going to have to form 2 because we want the apothem and we want the half side, the opposite side and the adjacent side. So we're going to have to use 2 ratios because we're only given one known, and that is the hypotenuse. So our first one we can use is we want to use, let's find the apothem first. So hypotenuse and the adjacent side. Okay, what trig function uses adjacent side and hypotenuse? That would be the cosine. So the first thing we're going to do is we're going to take the cosine. So the cosine of what degree? 22.5 is equal to the adjacent side, that's the side we're trying to find, over our hypotenuse, which is 16.2. And now we're just going to solve for a, which is really not that bad. What I like to do is I like to put this side over 1, and then I'm going to cross multiply. So the first thing I'm going to do is I'm going to do cosine 22, and I get 0.927. Okay, so we'll write that. This becomes 0.927. Okay, but I'm going to multiply this right away times 16.2. I'm going to cross multiply this one first. And I get 15.02. And then I do a times 1, and of course that's pretty easy. That's just a. So now I have my apothem. My apothem is 15.02 inches. Now I need to set up another trig ratio to find my opposite side. And I'm going to stick with using my hypotenuse and opposite side. So which trig function uses the opposite side and the hypotenuse? Well, of course, sine does. So I'm going to use the sine of theta, the sine of my angle. So the sine of 22.5, same angle, is equal to my opposite side. I'll just call it O for now, because I don't really want to call it S over 2. So I'm just going to call it, we'll use a black O. O divided by my hypotenuse, same thing, 16.2. And it's the same exact process we did before. Okay, so I already know that cosine of 22.5, or excuse me, now I need to do sine, not cosine, of 22.5. Oh, I just realized I made a mistake. Instead of doing cosine of 22.5, I did of 22, which makes a little bit of a difference. And I'm going to go ahead and see what that changes it to. It's going to be 14.9. 14.97. Sorry about that. 14.97. So this is 14.97 over here. 14.97 inches. Okay. So now I need to do sine of 22.5, and I get you should get about 0.382 for that. Okay, I'm going to multiply this right away, the whole thing. I'm not going to round it, times 16.2 because I'm cross multiplying here. Okay, this is an O, not a 0. Just keep that clear in your mind. I should have used a different variable, but let me just label it as OPP. That'll be better. Okay. So then I multiplied it, and I get opposite side times 1 is just opposite side, equals, and then we multiplied it, and we got 6.2. So my opposite side is 6.2 inches. I'm almost done. So 6.2 inches is this distance here. So I need to double it to find the whole side. So the side equals 6.2 times 2, which is going to give me 12.4 inches. Now I have everything ready for my formula. Okay, so let's plug it in. We have area equals 1/2 the perimeter. Well, I need to do 12.4 times 8. There's 8 sides in the stop sign, times 8. I get 99.2 times my apothem, 14.97. We fixed it. 14.97. Don't forget the 1/2 if you didn't do that. And I get area equals 742.512 inches squared. So I'm going to rewrite that as inches squared. A long problem, but trigonometry can help you solve any problem. Makes it a lot more relevant to the real world because real world numbers aren't super nice. Hope you found this video helpful, and I will see you next time.